I've shared with you why, or the primary reasons why, the Big Bang is believed by many to be good science. Now let's talk about why it's actually bad science. Let's go through the model chronologically. Here's how it goes. In the beginning, there was nothing, and then it exploded. What exploded? Nothing exploded. And nothing did explode because that's why there's everything here today to talk about nothing. Stephen Hawking explained how and why this all happened. He said, because there is a law such as gravity, the universe can and will create itself from nothing. Spontaneous creation is the reason why there is something rather than nothing. Why the universe exists, why we exist. He explained further, the laws of gravity and quantum theory allow universes to appear spontaneously from nothing. Notice the plural, universes. We'll talk more about that here shortly. Cosmologists like Professor Hawking frequently invoke the laws of physics to explain how the universe formed itself from nothing. But what is a law of physics? Is it capable of producing a universe? What does a law of physics look like? What does it feel like? What does it smell like? That's a stupid question, right? A law of physics is not a thing. A law of physics is actually a pattern, right? A law of physics is just that we have noticed a pattern of how the universe operates and formulated it, hopefully into a good mathematical equation that can be tested. A law of physics is not a thing. If it's not a thing, it can't create anything because a pattern can create nothing. More to the point, the pattern did not exist before the universe itself did, right? Because without a universe to operate, there's no pattern under which to operate. Does that make sense? So a law of physics can't create anything because the law of physics doesn't exist until there's a universe to display such behavior. Well, so if the laws of physics then couldn't create a universe, then who did? Who done it? Well, a more practical thing to say would be that various forces recognized by physics maybe did this. Now, physics recognizes four fundamental forces. I've listed them for you here. But according to the Big Bang model, when did these forces form? Before the Big Bang or after the Big Bang? And the answer is after. So if they didn't exist till after the Big Bang, could they have caused the Big Bang in the first place? Could the universe have created itself through these forces? Well, something can't create itself. Now we're running into philosophical problems, because in order to create something, it must first exist. For self-creation to be true, something must exist before it existed, which is obvious nonsense. And how do you go from nothing to everything anyway? In the beginning there was nothing, and then today there's everything. Well, we're told that nothing did it, but nothing can create nothing. Nothing can do nothing. From nothing, nothing comes. Right? R.C. Sproul once said, if there was once ever nothing, there could never be anything. And I like the way Dr. Phil Fernandez put it. He said, you can't tell me that nothing made everything. I know too much about nothing. So, now some people say, well, even if you wait long enough, even that which is extremely improbable will eventually occur. But that doesn't work either, because time itself didn't start until the Big Bang occurred. So there's no time to wait. Nor was there a place to wait, right? Because there was no space. There's also some very basic physics that are violated by the Big Bang model. Probably the most fundamental principle in physics is called the law of conservation of energy. Law of conservation of mass energy, to be more specific. And that's saying that energy and matter can't be created or destroyed. You've probably heard of E equals mc squared. This is a famous formulation of this. E stands for energy, m is mass, and then c is the speed of light, which is a very large number. So if you remember your algebra, that means that a little bit of mass equals a whole bunch of energy. Now we can convert things on either side of that equal sign. We can convert matter to energy, for example. The most efficient way we know to do that is a nuclear bomb. A little bit of stuff releases a whole bunch of energy. We can go the opposite direction, by the way. We can take a whole bunch of energy and make a little bit of stuff. We do that in particle accelerators. You get little pieces of atoms whizzing around fast enough, smash them together, more particles come out of the collision than went in. But we're not creating matter. We're just converting energy to matter. And as I said, you can go the opposite direction as well. Again, probably the most fundamental principle in physics. If you take physics in high school or college, practically every problem you solve, the first thing you do is assume energy and mass are conserved. Then you write the equation that reflects that, and then you solve it, and hopefully you did it correctly, and you get an A. But the rest of the world reflects the truth of this. That's why we need to eat food, because your body can't create energy. It has to get it from an external source. You need to pump gas in your car, same reason. Because your car needs to take the mass, convert it into energy in order to provide kinetic energy, which is motion, and so on. If you've ever gone on a diet, you're relying on this principle being true. You're relying on your body's inability to create energy. You want to use up stored energy that you've unfortunately accumulated over the years. But the Big Bang violates this principle in the largest way possible. On a universal scale, literally. I mean, we can't violate this on a workbench in the laboratory, but Big Bangers tell us the entire universe popped into existence out of nothing. That all this matter and energy, poof, there it was.